So we are talking about the impact of measuring real-time occupancy changes and indoor quality on K-12 and higher ed sector. So we're asking about what are the best practices, what are the barriers to adoption, how does this help achieve goals of the various stakeholders to improve operational resilience, be in compliance with environmental safety and governance kinds of goals. So today we're really blessed to have an incredible group on different sides of the fence. We have Professor Mark Hernandez with the University of Colorado. We have Linus Grasel from the company Occuspace. We have Paul Volante from Chicago Public Schools. We have JJ Baird with Airthings. So we are starting today at 1 p.m. at Eastern. And I just want to let you know that we do this once a month. So next month on Friday, June 20th, we'll do on the use of digital twins and unified IoT platforms to serve as accelerants for peak experiences for landlords, tenants, and employees. So you'll see quite a shift in terms of the rhythm. And so we'll have different kinds of people. And so you'll see some different players come on. But let me close out my screen there and go around. I want to start with you, Mark. Mark, would you please introduce yourself in terms of, just name and what organization you're from and kind of your passion?
Sure. You already introduced my institution. It's University of Colorado at Boulder. That's where our in-state flagship engineering college is. I've been there 30 years on the research side, studying microbial air pollution, bioterrorism, measles, COVID, transmission in air, and interventions for that. That's kind of the research side. The practical side is why I'm here today, and that is trying to keep absenteeism rates in public schools low by improving environmental quality in an affordable and immediate manner. So I'm a civil engineer by training, like to translate things to practice. That's what I'm all about and why I'm here today.
Thank you, sir. I'd like to pair you next with Paul. Paul, would you kindly introduce yourself?
Sure. Yeah. Thanks for the intro, Ari, and thank you for having me here. Paul Volante, Facility Automation Architect for Chicago Public Schools. So I am in charge of a number of different OT initiatives throughout the district. I built all of our centralized building automation system infrastructure for the district, along with building our indoor air quality monitoring solution and all the infrastructure surrounding that. Also principally in charge of intercom systems and slash public address systems and audiovisual for the district. So just a few things. Been with the board for 25 years in a variety of different capacities. And actually a computer engineer by trade, and was a teacher, technology coordinator, and have done a variety of different things before I got into controls. So
what a blessing for this district to have you. Wow.
Thank you.
A wealth of experience. So next I'd like to go to JJ. Jay, would you please introduce yourself?
Yeah, absolutely. Hey, everyone. I'm JJ. I am based in Atlanta, in Georgia. I am the global VP for Airthings in our B2B division. And I kind of like the question about what is our passion. And I think I share the Airthings passion, the correct answer, which is I share the passion to help the world breathe better. But other than that, I have a huge love for aviation. And actually, Paul, I didn't know you were a software engineer. I was actually a software engineer for most of my career as well. About 10, 12 years of my career writing code, writing software. So great for the meeting of the minds.
Sure. Linus, who are you and what's your passion?
Yeah, I'm Linus Grasel, co-founder and CIO for Occuspace. Funny enough, I was a structural engineering major in college, and then I got my master's in machine learning, which is where I translate most of my learnings today into Occuspace, capturing, Bluetooth and Wi-Fi data to transform that into occupancy insights. A little bit more about Occuspace. We provide real-time occupancy data across hundreds, thousands of buildings across the US and Canada today, helping organizations maximize the use of their spaces, reduce costs, and just improve the user experience of all their spaces. As for a passion, I think just really my passion. I mean, over the last, since we've been doing this for the last 10 years, I've just really become fascinated on how deep the hole goes when it comes to the rabbit hole goes when it comes to optimizing space and all the different things that you have to keep in mind. Sometimes there's a lot of contextual information that just isn't as readily available, and it requires a lot of human interaction to work with the different stakeholders and understand what's important to them. And more recently, I've learned a lot about the overlap between, occupancy data and IAQ, and the different opportunities that exist to make just buildings more efficient and a better user experience.
Good. So I'd like to start from the sensor side first and work backward into the built environments, whether they're, K-12 or university and so forth. But before we do that, I just want to emphasize to the folks participating, and first of all, welcome to the table. And if you have questions, if you want to direct them to a particular panelist, just put them in the chat, and Sky and myself will try to do our very best to navigate that. And roughly, 10 minutes before the close, we'll try to make sure that we get those. And Sky, please remind me if I don't do that. And all right, so I want to start with JJ. JJ, you have such an interesting background, both on the code and the sensor, now on the transactional side, and you see a lot in terms of what's happening at K-12, what's happening at university, what's happening in corporate, what's happening in government. But fundamentally, and I don't mean to, belittle the crowd, but what is and how do you measure air quality, and what are some of the trends?
Yeah, so certainly indoor air quality or air quality is essentially just a measure of what is in the air that we breathe. And that could be a variety of different things. So these could be natural things that us as humans aspirate into the air, or it could be pollutants coming from sort of third-party sources. And then we view air also as something that is environmental. So the things that have an impact, like things like the light and the noise that's in the spaces around us as well. If we look at sort of what are some of the trends that we're seeing, the first big trend is Airthings is both a consumer as well as a business organization. And so we're certainly seeing major adoption of IAQ within the consumer space. And it's also driving organizations and schools to say, are we ready for the onslaught of the amount of consumer devices coming into our spaces? Because people now have the ability to bring these spaces in to work with them, or kids can bring them to school and actually respond and say, this is actually what our sensors are saying. And sometimes a school or a business doesn't actually have anything to back it up.
JJ, is this being driven by the pandemic experience, or is it being driven by pollution in general, or some of the crazy forest fires we've been seeing?
So it's actually a combination. I think what happened as part of the pandemic is air quality just became something that people were aware of and something that people started to show interest in. I think since the pandemic, the reason for using air quality has shifted from the thought of, are we reducing virus impact in the spaces? Are we going to get sick because of COVID? But more saying, what is the well-being aspect? How do I perform better when I am working and breathing in an environment with good air quality? But I think if we think about what's driving indoor air quality adoption today, I think wildfires are continuing to be a major force within that space. It doesn't show any signs of slowing down. Earlier this year, we obviously had the huge wildfires in California and in Los Angeles, and that continues to drive how consumers, as well as businesses, as well as schools, are adopting. And I think the fact that people are becoming more aware of what this all means is they're saying, is it actually safe in my home? This is something that I cannot see. It's sometimes something that I cannot smell, but it has an impact on how I feel and how I perform every day.
Listen, this is another, environmental vector, which is, it's topical. And so I remember growing up, the space the viability of space exploration really started to hit in the late 60s, early 70s, which I know ages me. But I was fascinated by that. That drove me to become an engineer. A lot of people I know also, it drove them. But let me move on to occupancy. So Linus, you and the leadership of Occuspace have developed a device, but first of all, what is occupancy, and why is it relevant, and what are the different, I guess, layers, and what are the trends? When I say layers,
Yeah,
I don't mean just counting people. I mean dwell time in a particular part of a building and things like that.
absolutely. I mean, occupancy is all about measuring how people utilize space. So at the core of it is counting people and observing, how long people stay in a space, or which is dwell time, or how many unique visitors a space may see. The tricky thing about occupancy data is that there's so many different ways of doing it. And for us at Occuspace, the number one thing when we designed our technology was to do it in a privacy safe way. We never want to be able to infringe in the end user's privacy. So we've designed a sensor that capture Bluetooth and Wi-Fi data anonymously that cannot be traced back to a single individual. And so that's what we do, and that's what occupancy data is. But as for the trend and why it matters, is that, depending on your organization, but I think universally it's pretty true that real estate is often the second largest expense after payroll for most organizations. But many teams still lack visibility in how their space is being used, and so that's what we help organizations just better understand, how well they're making use of their space. Do they need to lease new space? Do they need to build a new building?
And of course, it also informs the systems in the building, like the HVAC systems, whether they should turn on or turn off, and so forth, and the facilities management services. All right. So let's do this. So now we know from the IoT sensor point of view, and we know the definitions of IAQ and occupancy, at a general level. I'd like to now talk on the user level, and I'd like to transition there. I want to get to you, Paul, but I want to transition there through Mark, because Mark, if you could kindly describe some of the work you've been doing for years to understand the impact of especially air quality on various variables in schools in K-12, in particular on, for example, absenteeism or anything else you'd like to bring up. And by the way, to all of you, if you have any data that you want me to queue up or you want to queue up, please, just, whatever you think is relevant. So Mark, please.
Sure. How's my audio? Okay.
It's perfect.
Yeah, great. So I'm going to come at this for my most recent experience, but you're right, it goes over many years, and my stakeholders are adolescents and children in school, and I'm going to extend the definition of air quality to include environmental quality. JJ mentioned a little bit about that, and so it's going to be air, light, and thermodynamics. That is the thermal comfort of children in these spaces. I look at all these at the same time because I'm an educator, and it's the quality of the educational environment that dictates learning ability. If you're not comfortable, if there's not enough light, if the air that you're breathing isn't optimized, then your learning can be compromised. So that's the angle that I take. If you want to share slides, I'm going to do this by example, Ari.
Sure. Let me.
I am fortunate enough to be funded by the Centers for Disease Control, and we're going to go to the first slide, give you something what I'm up against. So I'm at our state's flagship university, and here in Colorado, we've outfitted more than 6,000 classrooms across the state with very high quality monitors that measure, or pop it around a little bit here, thermal comfort, measure, or thermodynamic indices, various aspects of air, both particles and gases, particularly CO2, and microscopic particulate matter that's in a respirable size range, as well as some chemicals, ozone, carbon monoxide, and so on. If you can show the map here so I can give the audience an idea of scale. So our state, population-wise, is not very big, but land-wise, it's quite big, and it has a huge diversity of geographic regions. The tallest mountains in the country are in our state. And we have an urban environment just to the east. We have plains on the east, and we have mountains and desert on the west. So the buildings are built very differently in these regions. They're operated differently. They're heated and cooled differently. And we see extremes, right? Especially at altitude and in the Southwest and the desert. So monitoring the thermodynamic and air quality factors along with energy is our jam, because we need to optimize all this. And the real question, and this was obviously driven by the pandemic, as you brought up, go to the next slide, please, is in the absence of intervention, and Linus brought up the importance of occupancy. We normalize everything by occupancy. The question is, go ahead and do the first regression there. What we're regressing is this gases, air exchange, CO2 levels, the microscopic particulate matter that the kids are breathing, and absenteeism in the absence of any intervention. We got $50 million, next slide, from the state to put in high efficiency air filters actually in the classrooms with the kids. And the question becomes, we bought 70,000 of these things, so they're all over the state. And based on ventilation performance, we distributed these to different classrooms. And the question becomes, if we improve air exchange and remove particles with these simple, affordable in-classroom HEPA filters, do we change absenteeism? And we're disaggregating absenteeism based on infectious disease, based on allergy and asthma, things that are associated with air quality and thermal stresses. So that's the question at hand. We've collected 4 semesters of data, and we're hoping next spring we'll actually see if we can see this, and if it disaggregates by region, rural or urban schools, if it maps with heating or cooling mode, if it maps with, as we brought up, and of course it does, with wildfire, local wildfire. Fortunately, we haven't had much in Colorado the last couple of years, but it's there. So that's
Mark,
what
I'm not a statistician by turn of living, but this looks like a pretty tight distribution. Am I imagining things?
You are not. This is a cartoon replica of the data.
Okay.
We have to run these. We have to run these regressions. After we run them, we have to provide them to the CDC project officer. They have to vet those, provide them to management before we actually produce our conclusions. So I have to say right now, these are work in progress.
Okay.
These data are recreated to make the point, but they are not, the actual p-values from statistical multivariate regressions. This is complicated by the fact that kids are not just in school where they're exposed. We have to pull out any community exposure. So we look at the different zip codes for spread of infectious disease, flu, influenza, flus, COVID, RSV, and so on. So we work with children's hospitals in the area to see if these data are confounded. The school's exposure are confounded by local spread. So that's what we're up to here in Colorado.
So,
and obviously
Paul,
we use.
Go ahead, please.
Go ahead. Yeah, we use the monitoring technology described by Linus and JJ in the classrooms. How many kids are there? Verified by the teachers. What's the air quality? Verified by high quality air quality monitors all day, every day, in every school.
I do want to get into the interaction effects between those two measures, but before I do, Paul, this must this must be very familiar to you. I know you maybe tell us a little about some of the studies you've done and some of the implementations you've done and what you're learning from these three gentlemen.
Sure. Yeah. No, occupancy as well as air quality measures and looking at environmental concerns are all things that occupy my time on a pretty regular basis. As sort of common thread with any kind of pollutants such as the wildfires. We actually had a roof fire at a building just recently, but with all of these events, monitoring air quality has always been for CPS a very important thing, even prior to COVID. And as such, one of the things that we're finding is the need to have data to be able to provide to our occupants as well as our constituents within the district. And so data is king for us. A great example is just recently, as I mentioned, we had a roof fire at a building, and immediately after, our teachers union was asking us for for proof that the area was safe. And so normally in the past, we didn't have air quality monitors in the building. We would send in our managing environmental consultants to do sample analysis, but that's only a spot in time. That's not a continuous monitoring that's done at that space. Luckily, we had indoor air quality monitors installed and starting to do data collection prior to the fire event. And we could see a direct correlation to the increase in particulate matter and TVOCs during the event of the fire to exceed what would be safe for occupancy. And I should preface, during the roof fire, nobody was injured. This happened in the evening. So sorry, I missed that in the beginning. But then what we saw is a near almost instantaneous reduction once we got our ventilation fans going, once we got our decontamination equipment running in the building. And with that data, we were able to show conclusively across all the rooms within the spaces to our teachers union that it is fine. It is within more than perfect from an air quality standpoint. There might be a little bit of a residual odor, but we are good. And that basically
that's amazing. So you had the data to support it. And by the way, if you have any screenshots you want to share, please feel comfortable. But that's got to be frustrating for a typical person who wants some time off.
Well, you get a variety of different complaints. We have the whole gamut of things with. When it comes to air quality, the building that I'm usually staffed out of, big timber building, and there is the perception of poor air quality because the bead blasting material that comes off of the timbers occasionally comes down, or sometimes there's some emulsification of the brick that falls down. Perfectly harmless to the occupants, but there's that perception. And if you don't have any data to back up that it's good, or sample data, or even continuous monitoring data, then you're basically behind the eight ball when you get into a confrontation. We routinely get staff who want to work from home who are not allowed to complain about air quality, and unless we have data to back it up, we can't really make a good case for them to not do that. So
that's interesting. Do you have an app that they can look at, or is it something they have to go? Like how do they? If I'm a teacher in your school system, how do I know?
Yeah. So the challenge with total indoor air quality monitoring, we're looking at a variety of different data points. Some of them require interpretation and specific dwell time, and monitoring, looking at a number of different components. So we do not directly expose our air quality data to our occupants. That's for our managing environmental team. So those folks have it. Our building operators also have access to those dashboards as well, because they've gone through the required training and understand the SOPs that we have in place for responding to an event. If there's ever a perception of air quality issues by an occupant in the space, that there's a specific escalation procedure that we have that we immediately go within.
Paul, the image that comes to my mind is Mark's graphic on the second slide where he shows the distribution of schools, in the state, and I'm thinking there might be like a red, yellow, green, where red is like warning, I was thinking of Lost in Space, but I won't go there on that metaphor. But anyways, warning, don't come into the space, and yellow is what's up, and green is good to go. But I also understand there might be some contingent liabilities there, so it's tricky when you share too much.
So, to that end, 2 points on it. I mean, our motto is warm, safe, cool, and dry environment. Also, air for is part of that. That we should kind of dovetail that in there. So our guarantee to our occupants is you will have a warm, safe, cool, and dry environment with great air quality. Part of the benefit of Chicago's ventilation code is during the pandemic, the requirement is 6 to 9 air exchanges per hour in a classroom space. So because of that benefit, we met ASHRAE's requirements for dilution of the actual spaces. So by carrying forward with our modern buildings, we meet or exceed all things there. So it's really more pinpointing any kind of points of escalation. But when it comes to data and looking at like data convergence of different things, so one of the things that we're working on right now is a data convergence project with our ventilation data, our indoor air quality data, our utility consumption, as well as our work order management to bring it into a geospatial system that we have, which will map all those events, and then we can set triggers as to what levels we want to show, and expose that to our leadership team so they can look at the district as a whole and see where there might be any anomalies, so we can immediately execute on that.
Gosh, Mark, I love your feedback on what he just said. I mean, that seems like you're giving kind of one version of the truth, and you can see it visually.
Right.
Mark, what's your reaction to that? It seems like the two of you could co-write the most beautiful white paper.
My reaction to that is jealousy, because we definitely don't have 6 air changes in most of our classrooms. Don't meet that. And I don't know if you saw that beautiful building on the first slide that you put up. That school was built in 1923. We have a lot of historical structures that are schools in Colorado, and the state code is those modifications must keep the facade of the building both inside and out as they were if they're designated historical buildings.
Wow.
So ventilation improvements become a challenge.
It's interesting. Good.
Well, especially with the extremes of climate that we see in Colorado. I mean, I know Chicago gets a cold winter. We, depending on the elevation, can get extremely cold and extremely warm here. And our buildings aren't, they're aged, and we can't modify them. Certainly new ones we can. So meeting the 6 to 9, meeting hospital air change in these environments is challenging. And what we've done is added those with lower air exchange, we've added in-room HEPA filters to help with that. So, until, the money comes for the modifications that we need.
Mark, your comment was inferencing into the next question in my mind, which are barriers to entry. And never in 1,000 years did I imagine that, maintaining the historical or being in compliance with historically designated buildings was going to be a barrier to entry over health. Like, I'm thinking these 8-year-old kid, like, what's more important than his or her health? And apparently the facade of the building. So it kind of blows me away. I guess I'm kind of idealistic.
I should preface that by actually some of our highest performing buildings in terms of ventilation performance, and even energy consumption, if you believe it or not, other than the window panes, are the older buildings. Some of them are like really great if you can open the windows, or if you can use the mechanical system in the building. But some of them don't have mechanical systems at all. They're just centered double. There's a central shaft and out exterior windows, and that's how they ventilate. And when you can open them, they do great. But yeah, so it's variable. But the key is you can't manage what you don't measure here. And
right.
I'm sure JJ and Linus will agree that the barrier to entry in understanding our buildings at a level to really help and measure learning effectiveness requires a whole new generation of monitoring. And that's absolutely key. So, we have thousands of classrooms monitored up, and that's how we assess priorities. Kind of like what Paul just said is, we use these. The data is king, and we're still in the process of outfitting all the classrooms with high quality
Sure.
monitors that we can trust the data from.
Listen, we need to make the classroom smarter. I'm curious, maybe if Linus or JJ, if you could lead this next part of the discussion, which is, from your perspective as OEMs, what are the barriers to entry when you deal with whether it's a school system or whether it's a university? I know Linus, the core of your company has been universities, but also with enterprise, some of the corporations. Please, either of you.
You tell me who you want to start. I've got a list of things if you want, but
I want you and
Linus,
Linus to self-select.
Go for it, JJ. Go for it.
Okay, perfect. I'll give it a shot, and then Linus, you augment with what I've said. So the first thing that we see in terms of a barrier is just fear. I think administrators and people who have buildings and people who manage buildings, they have a fear that if they put monitoring in, they're scared of what they're going to find. And they also think that if they start monitoring and they find something that's bad, that means they actually have to do something about it. And there's actually a legal liability associated with that. And to that, I'd say, it's always the same answer. It's people are bringing in their own sensors. Whether you know something is there or not, it doesn't make any material difference whether it's actually happening in the spaces or not. The only place you can go from actually starting to monitor is actually improvement from that point, which will drive, organizational improvements. It'll drive improvements within kids' test scores, and there's only positive to be gained from it. I think another issue that we see is a knowledge gap. So what people do is they get all of this data and they have no idea what to do with it. And they go, yeah, we get it. Like, we have all this data. It says it's bad, but what does it mean? What do we do? What is the next step that we take? How do we convert data into actually doing something? Another thing, and I think it's interesting, Mark made some really good points, and he's been working on a study for a long time. And this really goes into that idea of showing ROI on good IQ can sometimes be a very difficult thing to actually make the connection. It's very difficult to say one-on-one, this is what the cause and effect was. But even though it's very clear based on studies, it's just because there are so many other variables in a live environment that could have an impact. And then the last one is just old facilities, and funding. Like sometimes especially school systems, districts just don't have the funds to do anything about the data. And that kind of just makes it tough in terms of that barrier to entry.
That's fair. Linus?
Yeah, I think you nailed it. Yeah, it's fear of being monitored, and what the data means, right? For us specifically, we have, the vice chancellors of universities who want to deploy this to make the most out of their real estate, but they just face a lot of almost political opposition from faculty. Faculty might not be using their space the most, and they're afraid of losing it, right? And so, or they're afraid of being monitored. And so there's a lot of education that needs to happen about no, you're not just going to lose your space because you're coming in 3 times a week instead of 5 or something like that, right? There's a lot of education that needs to happen about what the technology does, what the technology captures, and what is going to happen. And then also, like JJ said, yes, there's also a knowledge gap with the users of this data, right? It's in higher ed specifically. There's still a lot of hand holding and education that we at Occuspace need to do to help, our end users to make the most out of that data.
So thank you. I want to shift in a moment to achieving educational outcomes, whether it's graduating on time, whether it's achieving certain grades and so forth. And I know that Mark and Paul are subject matter experts on those. But before I do, I'm just curious because I got teased by Paul a little bit here. What are some hero moments? Like he showed a hero moment when he had the data to show, okay, it's safe to go back to class after that fire. Do you all have any hero moments where maybe in the last year or so, one of your clients, whether you want to stay anonymous or not, said, "Whoa! Without your tech, I would have been devastated." Linus, you want to go first, or JJ, you want to go first?
Yeah,
Is there some?
certainly.
Yeah,
I can showcase a little bit of some of the stuff that one of our clients. I have like some screenshots prepared,
please go
but
ahead.
one of our clients over here, they essentially used our data to. This is a classroom at one of our. Can you guys see my screen?
Yes, sir.
Okay, so this is one of the classrooms that we were monitoring, and you can look at what the average utilization was and then peak, and it was really interesting for them to see, that in the first couple of weeks of school in the semester, the data was much higher, and then throughout the semester, the peak utilization just starts going down. So it was just students not going to class as much. And what was really interesting was also they started to look at a little bit of what the trends looked like for the utilization data for the same classroom, at different hours of the day. And they're now starting to use this data to determine how to ventilate the space, right? So even though there may be classes around noon, you can see that around noon, the classroom is a lot less utilized. So they're trying to dynamically adjust their HVAC system to ventilate based on how many people are in those classrooms. And they also have IAQ sensors in the space, so to make sure that your relative humidity, the CO2 particles, and your VOC are still within the ASHRAE thresholds. And so there's a lot of excitement around merging both occupancy data and IAQ to better optimize the classroom experience for students, because specifically in this case, the user or our client believes that the classroom might be over ventilated, and they fear that throughout the quarter the classroom attendance rate may have been dropping out because of it. So they want to experiment with it and see what kind of impact it has for the next semester.
There's also the other side of that, which is it consumes more electricity than necessary. But
absolutely.
So JJ, any thank you for sharing that data. So JJ, any thoughts? Is there a hero moment where your sensor was like, yeah, perfect?
Absolutely. So I'll share some slides. I've got a couple of them that I can quickly show, and then a couple that I could just talk through.
Mind putting it in presentation?
Yeah, absolutely. Absolutely. Let me do that. Okay,
Thank
perfect. You. It was just if I was going to have to switch between different decks, I kind of had that ready. But in terms of a hero moment, this was a pretty big one, pretty cool. What we found is every time, this was in the winter time, every time the heat started increasing in the space, the amount of VOCs was actually increasing. There was complaints in this particular space where people were saying they have headaches, they can't smell anything, they can't see anything, but something in the space doesn't quite feel right, and they just don't feel well in the space. And what we saw is, again, every time temperature went up, VOC went up really sharply into sort of red zone levels. You can see here sometimes going above about 4,000 ppb, so parts per billion. And what they found is when they did an investigation, they found that when in the mechanical room, there was a test port that someone never kept back, and there was combustion air blowing into the room, getting sucked back into the system and dispersing that air all over the space. So that was a pretty cool moment and a pretty cool thing to see. Another one that we saw sort of with occupancy data was a teacher was using candles in the classroom that also caused headaches for some kids. And they actually saw the attendance rates on that class actually be lower than others related to CO2 values and test score outcomes. We've certainly seen a clear correlation there, but also we found that in classrooms where CO2 was exceptionally high compared to other classes, it started an investigation, and they were actually able to see that someone painted over some of the ventilation grates.
Oh my goodness.
Yeah, so a lot of
that was your procuring cause for the work order. Interesting.
Exactly. So a lot of interesting things that customers have been able to see, and I just and we can come back to some of these other points that I had here, because I put together some slides of actual customer use cases, and these are actual schools where we've done analysis on. You'll see,
because after you do this, I want to get the reaction from Mark and Paul, because I care about the educational outcome.
Oh, for sure. Yeah. So, and I just wanted to show how strongly correlated occupancy and IAQ actually is, because, we're talking about occupancy today, we're talking about IAQ. And down here, you can sort of see some of the occupancy rates that we auto-calculate. This is not hyper accurate, but it gives just a range. We always recommend that customers use proper occupancy sensors, and it really helps customers figure out what is the source of the issue. So, for example, I can see a clear correlation between CO2, and let me just make this a little bit bigger so you can see what I'm referring to. So you can see a clear correlation between CO2 here and occupancy rates. You can see lower occupancy, lower levels of CO2. Clear correlation between occupancy and VOC rates, but you can also see when the systems are turned off at night, the space itself is actually emitting VOCs. It's not coming from the humans necessarily. There could be a part of it that's coming from the humans when ventilation is turned on, but when ventilation is turned off, we're clear that the spaces are emitting those as well. And then you can also see what is the impact of non-ventilating times and outdoor PM levels with unoccupied and occupied times within the building. So there's a lot of value that you can drive from combining occupancy data and indoor air quality data.
We're in the last 3 minutes of our discussion, so I want to give Mark and then Paul, I guess, the last word. Mark, starting with you, what's your reaction to what you just?
Well, my reaction first is, Linus, you need to show that attendance data to their parents, whoever's paying the tuition. And what I hope we come away with is these data are valuable. We have to be careful with what we say is safe or not. Correlation means a lot of different things to a lot of different people, but the point is what's normal and what's not. That's what we can get from this valuable data set. In closing, I cannot yet make any conclusions from attendance or infectious disease data yet. Ari, stay tuned. Spring 26, we'll have that out. Epidemiology it takes a while, and we have to be careful with our conclusions.
Of course.
So do we say
review? Sure.
Do we see trends in air quality attendance? Absolutely. Are they significant? I got to hold on that statistical power. Stay tuned. A little bit less than a year, we'll have that. Thanks for including me.
Of course. Paul, you get the last word.
Wow, all the pressure. No, we definitely see, one of the things that we're excited to look for is, as I was mentioning earlier with our data convergence, is overlaying the data that we're seeing from both our HVAC, our indoor air quality, on top of student attendance and performance data in our geospatial system, to be able to see if we can see any measurable outcomes in those particular spaces, as well as compare buildings. But further on the occupancy data, one of the things that, and I was trying to furiously respond to the chat about that, but I guess I'll just speak it to here, is look at where we can take the occupancy data coupled with indoor air quality data and our HVAC data to look at where we can go beyond like high performance of sequence of operations. So people are probably familiar with ASHRAE's high performance sequence of operations. Apologize for the noise in the background. UPS just showed up. Always on time, and take those sequences and modify them then to include the individual unit information for occupancy to be able to truly look at where we can tease out additional savings for the district. So I'm hopefully in the next year or so, as Mark is collecting his data, I'll be collecting mine, and we can circle back and say we've seen a lot of positive momentum or negative momentum, or it's flat.
We'd like that.
Yeah.
I'd like to see some kind of document come out from this and presented to this to the AEC or MEP community. I think it would be very valuable because each of your perspectives that you shared today is vital to navigating this path, and we kind of put aside all of our emotions and focus on the on the data. So the data tells a story. So thank you everybody for making time to be part of the panel, and thank you for participating as an audience member. So on behalf of KMC Consulting and KMC Controls, I bid you a safe and healthy Memorial Day weekend.